This time we're supposed to convert 39 and 291 thousandths to binary. We're going to convert the whole part first. So 39 is nothing else, just 32 plus 7. So I have 32 and 7 because 4 plus 2 is 6 plus 1 is 7. The empty spaces I have to fill up by zeros. One more time, 32 plus 4 plus 2 plus 1 is going to give me 39. So we've finished with the whole part, fractional part. Now, it could be kind of difficult to guess what numbers we're supposed to add together. So what we're going to do, we have to perform the subtraction like we did before. Simply write 0.291 and ask yourself question, what is the highest weight which I can subtract from this number? The answer is 0.25. Subtract. And you are going to have 1, 4, 0, and 0. The highest weight which you can subtract from this value is this one. I have 0.03125. Add zeros, perform subtraction. And I'm going to have 10 minus 5 is 5, 9 minus 2 is 7, and I have 10 minus 1 is 9, and I have 0, 0.0. So let's take a look what we have subtract. We subtract 0.25 and we subtract 0.03125. Now this value is less than the lowest value of the weight on my board, and we said we want to keep just 5 binary bits. That's why I'm going to stop at this moment and simply fill up the empty spaces by zeros. That's why my answer is going to be 100,111 point. This is my binary point 01001. This is binary number. This value is not going to be exactly 39.291 thousandths, but it's going to be close enough. If you want to get the value much closer to this one, you're supposed to extend this number by adding extra weights and perform the subtraction. But we want to keep just 5 bits after the binary point. That's why this is the solution to my problem. This time we have a little bit bigger number that we had before. We have 221 and 472 thousandths. Now, is take a little bit longer to find out which numbers we're supposed to add together in order to get 221. So I recommend to perform the subtraction. It's going to be much faster. And I'm going to have 221. The highest weight which I can subtract from this number is 128. And I'm going to have 11 minus 8 is 3, and I'm going to have 11 minus 2 is 9. I have 93. The highest weight which I can subtract from 93 is 64. Borrow 1, 13 minus 4 is 9, and I have 8 minus 6 is 2. The highest number which I can subtract from 29 in this case is going to be 16. We subtract 64. We have 9 minus 6 is 3, and 2 minus 1 gives me 1. 13. From 13 I can subtract 8. Subtract 8. So I have 13 minus 8 is equal 5. Binary 5 is 4 and 1. That's why I'm going to fill up these spaces by zeros. And this is my 221. Next, I'm supposed to find the fractional part of my number. Again, I'm going to perform subtraction because, in my opinion, this is the quickest way to get the answer. And simply write 0.472 minus, and the highest weight which I can subtract from this value is 0.25. And I have 2, 2, 2. The weight 0.25 I supposed to mark by 1 because I performed the subtraction with this weight. Next, I supposed to subtract this weight from this value because I can do it. So this is the highest weight which I can subtract from this number. I have 125. Subtract. Borrow 1 from here. This is 12 minus 5 is 7. And I'm going to have 11 minus 2 is equal 9. And I have 0. The highest weight which I can subtract from this value is this one. And I have 0.0625. Subtract. We have 0 over here, right? So I have 10 minus 5 is 5, and I have 6 minus 2 is 4. 9 minus 6 is 3. 0.0. I subtract this weight. From this value, I can subtract this weight. I have minus 0.03125. 10 minus 5 is 5. 4 minus 2 is 2. 4 minus 1 is 3. I have 0, 0.0. Please notice that this value is lower than the lowest weight which we have on the board. That's why I'm going to stop doing the subtraction and simply just mark this weight by 1 because I used that weight, and everything whatever I didn't use I have to mark by 0. Remember, we said that we want to keep just 5 bits after binary point. That's why I can copy my final answer, and this is going to be 1, 1, 0, 1, 1, 1, 0, 1. This is my binary point, and I'm going to have 0, 1, 1, 1, 1. This is the solution to my problem. Let's take a look at the board. Again, we're supposed to convert the whole part first. So that's why I'm going to write 105, and the highest weight which you can subtract from 105 is 64. 5 minus 4 is 1, 10 minus 6 is 4. That's why I'm going to mark 64 by 1 because I subtract 64, I use that. Next, from 41 I can subtract 32. And I have 11 minus 2 is 9. 3 minus 3 is 0. From 9 I can subtract 8. And I'm going to have 1. From 1 I can subtract 1. That's why this is going to be 0. I finished with my whole part of the number. Next, I'm supposed to find the fractional part of my number. So what I'm supposed to do is simply write 0.22853. The highest weight which I can subtract from this value is 0.125. And I'm going to have 3, 5. 8 minus 5 is 3. This is going to be 0. And this is going to be 1. The highest weight which I can subtract from this value is this one. But because I used 125 thousandths, I'm going to write 1 over here. Next one, as I said, I have to use this one. I have 0.0625. And I'm going to have 3, 0, 1, and this is going to be 4. This is 0.0. I used this weight, that's why I'm going to mark this weight by 1. From this value, I can subtract this one, and I have 0.03125. I have to borrow 1 from here, and I'm going to have 13, and this is going to be 9. 13 minus 5 is equal 8. 9 minus 2 is equal 7. And I'm going to have 10 minus 1 is equal 9. And this is going to be 0, 0.0. Please notice that this value is lower than the lowest value of my weight. That's why I'm going to stop perform the subtraction. Means my answer is going to be approximated. It's not going to be exactly this value, but we said we want to keep just 5 binary bits after binary point. That's why my answer is going to look like this. I have 1 1 0 1 0 0 1, and this is my binary point, and I have 0 0 1 1 1 base 2. This is the solution to my problem.